So, in order for us to answer the questions that we had from the previous class, we are going to consider this typical activity that we are given. We had the question on our line shaft, the given information that was from the activity and the diagram, also with questions. So we want to see how can we attempt such typical questions in case you have an exam of that nature. So this was actually FT, not F1, but FT. All right, no problem. We're gonna look into that one, and the rest. All right, the diagram from the information that we have, we are told that the line shaft in Fig 3.11 is supported by two bearings. And these bearings that are 800 millimeters apart, 800 millimeters apart from bearing 1 to bearing 2. So that is 350 plus 350 plus this 100 that was going to give us what? 800 millimeters, all right, if you are to combine these, all right. So that is what you have as the distance in between these two bearings. And we are also given that between the bearings is a flywheel. So there is what? A flywheel. In our case, we have got a flywheel. So this is very, very important, with a mass of what? 200 kilograms. And there is also a gear. So we have got the mass of what? The flywheel. Remember, I told you guys, once you are given the flywheel, what you need there is the weight. It's only the weight that you need from the flywheel. So definitely we must calculate the weight from there. Mass is given, so that's mass times gravitational acceleration. 200 times 9.81. All right, so that was gonna give us the weight of the flywheel. So here, this is gonna give us 1,962. All right, so we've got 1,962 Newton as the weight. Then a pulley is keyed. So if we take closer look, we have a flywheel. Then there is a condition of the gear. There's a gear also. So we're gonna consider the gears on their about their information. But there is also a pulley is keyed 200 millimeters from the right bearing. All right. So there is also a pulley 200 millimeters from the right bearing, which is what you have. So remember what happens with the pulley. It is the one that I said it is having tensions. All right. If you still remember, when dealing with the pulley, that's when you are having the tensions T1 and T2. So meaning to say, from the pulley, you are supposed to expect that. So there is a pulley. So they're going to consider those tensions T1 and T2. And also if there is any weight that is given, all right? If there is any weight, they can give you the weight of the pulley. In our case, we are not given the weight of the pulley. It's just the tensions. And according to those tensions, we can see that they are facing down. They are in the negative. These are the tensions T1 and T2 that you're going to determine. We are going to use that one as vertical. All right. The driven gear is keyed to the line shaft. The driven gear is keyed to the what? To the line shaft. it has a torque of 160. All right, so this is the torque, this is Newton meters. All right, so as we are to consider the gears, there is a driven gear. So on that, we have got its torque there, which is what? Which is given as 160 Newton meter with a pitch center diameter of 100 millimeters. So we've got the pitch center diameter or distance between, which is what? 100 millimeters divided by 1000. That's 0.1 meters. So this is what you have. A motor drives the driving gear. All right. So the motor drives the what? The driving gear. Take note. When you have to consider the driving gear, it is driven by what? By the motor. Here's the gear ratio of what? 5:1. So we are given the gear ratio of the gears as what? 5:1. Remember, the gear ratio is used when you refer the torque of the motor and that of what? Of the shaft. All right. Remember that the gear ratio is equal to the torque of the shaft over the torque of what? The motor. In our case, the torque of the motor, it is actually the torque of what? The driving gear, because the motor drives the driving gear. All right. So that is, you must be very careful. Then the pressure angle between the gears is 20 degrees. So we have got the pressure angle of 20 degrees on the gears. Then the tight side and slack side belt tensions, the tensions T1 and T2 for the pulley. It is the one that has what? The tensions. So we are given the tight side, that's T1, slack side T2. So T1 is what? 2,800 Newton. T2 is what? 1,825 respectively, as we are given. So that's your information for now. And the diagram that we are given, which is also an illustration of what is given there. So the questions were calculate, which is very, very important now. Calculate 1.1, the tangential force. All right, the tangential force, that's FT, not FFFT. All right, this is FR. So guys, these guys when editing, they just edit. All right, no problem. Sorry for that. So the tangential force, FT, between the gear teeth. The tangential force between the gear teeth. We talk about the gear. So this is going to happen. Remember about the gear, what we are given is the driven, where we are given the torque of the driven 160 and the pitch center diameter. So we can use that to determine our tangential force. All right, on our introduction, or not introduction, but on another video I explained here these formulas. All right, this one you're actually given from your formula sheet. All right, so your FT, remember I say these two, they go hand in hand, they are used hand in hand. So all right, just was application of the formula, this one. All right, all right, so let's just have our answer. So this was 1.1. So FT can be calculated. This is our tangential force. It can be calculated from the formula direct, straightforward, as we have got the torque and also the pitch center diameter of what? Of the driven. We can use that one. It'll be our FT. That is, you use, if you are given information about the driver, you use also this one for the driver. If you're using for the driven, but you obtain same answer there. All right, so that is it. 2 times the given torque is 160 over what? The pitch center diameter in meters. In meters, that's a 0.1. So we're going to obtain 3,200 if you have to simplify this one properly. So that's our FT. So that is direct like that, then followed um, by the radial force. All right, on 1.2, it was to calculate the radial force between the gear teeth. So it is the same like what we had. We can still use our formula, the radial force, as we have calculated FT, and we also have the angle of pressure. So the pressure angle is given, so you can simply use that formula for to calculate our radial force. So you'll be given those formulas actually in your formula sheet. So guys, it will be direct. So I want to actually attempt the one for the reactions. So here, let me just rush. The radial force is equal to what? From what? From Ft. It is given as Ft times the tan of our pressure angle. So that's Ft is given 3,200 times the tan of 20 degrees. All right. So this was going to give us our Fr, which is what? Which is the radial force. Okay. So let's calculate this one. 3,200 times the tan of what? 20. So this was going to give us 1,164.705 to three decimal places. All right. So I'm just going to use three decimal places. So this is what you have as what? The radial force. So I want you to understand here that we need to consider again from our diagram, how are these two given, Ft and Fr? Ft and Fr. How are they given will affect the questions to follow. They will affect the questions. So we must be very, very careful of our information. Ft. Because here on 1.3, the question is to calculate the vertical reactions on the bearings R1 and R2. All right. So how do we calculate now these vertical reactions? We look into our information and the diagram. Remember the forces, all the forces and weights that you must have, that you are supposed to expect if you're dealing with a vertical. Is there a flywheel? Is there a pulley? Are there gears from the given information? Those are going to be part of your vertical. Same, we have the effect on the horizontal, only that on the horizontal, the flywheel won't be applied. But for the vertical, this is what you need. So we look into what we have. There is a flywheel. So this is going to affect our vertical. So that's 1.3. So we are to calculate vertical reactions. All right, vertical reactions. So I said there is a what? A flywheel. So you must consider that. A flywheel has to be taken vertically because of its weight facing downwards. The weight will be facing down. So meaning to say here, there is a weight to be taken facing downwards. Remember, we have that weight from the information I told you. First thing, calculate the weight. So we have got the weight, 1,962 as our weight. Moving on to the gears now. what is going to represent the vertical? According to what we have, this is our driven. This is our driver, sorry, our driver. Our driver is below. This is what is happening. Our driver is below. So what is happening? The FR is in the direction of the driven. So the driven is on top. So in the direction of the driven, our FR will be facing up. As we have got our FT to the left, as it is given, FT horizontally. So the opposite, FR and FT, they oppose. If FT is the one that is given in the what? In the vertical, FR is going to be horizontal. So according to our information, the driver is below, so it pushes the what? The driven up, as it is on our question. All right, I think we had talked about this condition when the driver is what? Below, pushes. So FR acts upwards, used in vertical reactions, and FT will be horizontal. So meaning to say, as we are to consider the gears, all right, the part of our gears, what are we going to take in the vertical? It is FR. So they are to be taken. And we are to take FR, and FR is what? Is going up. As we can see from our information, this is below, the driver is below, so pushes this up. So this is about the gears. Then we move on to the pulley. We move on to the pulley system where there are tensions. So you must consider to say those tensions that are given, which direction are they facing? The tensions, they are facing downwards. They are tensions. And for the pulley, it always, if we go back to what we had before, affects our bearings. When it is going up, it means we're going to have this one going up, but the bearings now will be taken in the other way, in the opposite direction, facing down, which you have to rearrange your diagram now to be in that manner. You have to rearrange your diagram to be in that manner. But in our case, what we are having here is exactly in the direction that we need. They are going down. The tensions. So it means our bearings will be experiencing an upward force opposite to what we have on the what? On the pulley. So the pulley is always going to affect here in the opposite. So means say we're going to take our bearings in the what? Upward. They are affected by an upward force, the opposite of what we have on the pulley. So this is it. And the pulley is what? Is going down. These two, they're going down, facing downwards. T1 plus T2. So we have to consider the pulley also. So the pulley has to be taken. So it is going what? Downwards. It is facing downwards. So this is T1 plus what? T2 going downwards. For the gears, we say it is going up, which is what? Which is FR. So that's our FR there. So these are the ones that you're going to use. Just like that. You apply your moments. You're done. So meaning to say, in our case, everything has to be considered. All right. Let me just quickly redraw this one in a simple drawing that we can all understand. So meaning to say, we are going to have something. All right. This is too much. Let's have this way. All right. We're going to have a simpler diagram like this. All right. So remember, there is a bearing on the left, this one, R1. So you're going to have our R1 and facing up 100 millimeters. So you can use millimeters as it is, you can use them, or you can use meters. Divide by 1000, 0.1, 0.35, 0.35, 0.2, 0.8. All right. So there is R1, which is at the end as it is. So that will be facing up. So that will be our R1 from the bearing. From that, there is what? A flywheel. So a flywheel has to be taken because of what? The weight. So facing downwards. So there is a weight. So that's it. This is our flywheel. So what we are using there is the what? The weight of the flywheel. All right. So that is it. The distance between is what? 0.1 to the left. That's 0.1 meters. So this is what you're gonna have. From the flywheel, we move on to the gears. So to the gears, we are going to take that one, which is what? FR. So we're gonna use FR there on the gears, and our FR is facing up. So this is it. This will be your FR like this. So just like that. And the distance in between is what? 0.35. From the 350, it is 0.35. 0.35 meters. Then from that, we also have a vertical. All right, here we're going to have the bearing before the pulley. There is going to be a bearing as our support here. So that's the second bearing. This is the first one. So we're going to have our R2 here. The distance in between is what? 0.35 meters. All right, so here it's 0.35 meters. Then at the end, right at the end, we have got a pulley, and it is to be taken because of what? T1 and T2 are vertically given. So we must consider them going downwards as it is here. So we also have a pulley. All right, so this is our pulley. So we are going to use the total T1 plus what? T2. For the what? For the pulley, this is T1 plus T2, the sum of those tensions, just like that. The distance in between, that is 200 millimeters, which is 0.2 meters. So that's 0.2 meters. So this is what you have. You can calculate these reactions, R1 and R2. You can calculate this. So as for me, guys, I'm just used to take my moments about R2 first. So it is up to you guys. So taking moments about what? About R2. It means I'm gonna calculate R1. All right. So let me take anti-clockwise moments to the clockwise moments. All right. Which ones do we have in the anti-clockwise? Remember, anti-clockwise this way. So anti-clockwise to R2. R2 is our reference as we have it. So it means we're gonna have FR because it's gonna be going like this. All right. So this is clockwise, sorry. Anti-clockwise here it's gonna be like this, anti-clockwise. So you're gonna have W going to this in the what? Anti-clockwise. This one, it is because of where it is facing up. So when it is facing up, it means when it is going to R2, it's going to be like this. This is what? Clockwise. The clock moves like this. So FR to this one, it is clockwise. All right. The pulley to this one, it is moving like this. Which way is this? Clockwise again. So this is clockwise. What about R1 to R2 like this? The clock moves that way. All right. So that is a clockwise. Okay. So the only part that is anti-clockwise will be like this, facing this. moving like this, moving like this. All right. So if it is moving in this manner, clock. So the anti-clockwise, it is just one, guys, the flywheel. So that is it. So the flywheel is the weight times the distance to R2, 0, 0.5 plus 0, 0.5, that's 0, 0.7, plus what else? That is the only one. That is the only one. So we take the clockwise. So clockwise, there is R1. Let us start with R1. R1 back to R2. So that's R1 times the distance is going to be what? 0, 0.8. Remember 800 millimeters. We add this. That's 0, 0.8. 0, 0.8 plus we also have another one in the clockwise FR2 R2. So you're going to take that FR times the distance 0, 0.35. You also have the pulley T1 plus T2. So that's T1 plus T2 times the distance back to here, which is what? 0, 0.2, just like that. So this is it. Let us fill in. The weight is given. You remember we calculated this, the weight of the flywheel, 1962. So that's 1962 times 0, 0.7 is equal to R1. Remember, you must calculate R1 about R2. It means you are to calculate what? R1. So that is it. So R1 times 0, 0.8 plus our FR. We calculated this one. FR here, it is what? That is the value that we obtained, 1164, comma 705 times 0, 0.35, the distance in what? In meters. Just like that. Then we move on. T1 plus T2, the tensions. Remember, you were given this. You did not calculate, but you were given these two. So you add these two. That was going to give us 4,625 Newton. So that's the sum of those two. 4,625 times what? 0, 0.2. So with this, you can find the value of what? Of R1, which is our unknown. So that was it. So simply combine. If you were to combine the left-hand side, those two, multiply, it was going to give us 1,373.4, which is equal to R1 times 0, 0.8 is the same as 0, 0.8 times R1. Plus, you combine these two from your calculator, that's 1,000 is 1,332.64 675, something like this. All right, which you can take to the left hand side and becomes a negative. All right, so you're gonna take it to the left hand side, that will be a negative. So if you subtract, you are going to get 40,75325, something like that, which is equal to 0, 0.8 R1. Remember, you are to determine the value of what? R1. So you have to remain with what? 0, 0.8. So finding R1, simply divide by what? 0, 0.8. You are done. 0, 0.8, 0, 0.8 here. So that was the value of R1, which was going to give us 50,942 Newton. All right, just like that. So this is what you're going to have. You have the value of what? Of R1. You can have it back to the diagram. All right. So with this R1, we can determine R2. This is 50,942 Newton. So meaning to say, we can determine R2 using forces now to say upward forces, sum of upward forces must be equal to sum of the downward forces. So you add everything that is what? That is going up to find R2. You add everything that is going up and add everything that is going down according to the presentation that you have there. All right. So in our case, it's R1. We have it. It is going up positive 50,942. What else that is going up? FR is going up. So you must add FR, which is going up. Remember, guys, the value of FR here. Okay, I was just supposed to write these ones here. Okay, no problem. But this is the value of our FR. So you must add 1,164,705. What else is going up? R2, the one to be calculated, is going up. What is facing up must be equal to everything that is facing down. So what is facing down? It is the weight of the pulley. I mean the weight of the flywheel. The weight of the flywheel, which we have here. So that's 1,962. What else is facing down? It is the pulley, the tensions of the pulley T1 plus what? T1 plus T2, which is 4,625. So just like that. You have formed an equation where you can calculate R2 from the forces. You are using the forces this time. So R2 was going to be equal to, so you take this to the other side, it becomes a negative. Take this to the other side, becomes a negative. So you're going to subtract these two from here. So subtracting that, you are going to obtain 5,371,353 Newton. So this is what you're going to have as R2, the reaction of what? Of the bearing, both being positive, R1 and R2, according to our calculations. All right, so this is your R1, and that is going to be your R2. So that is how you answer these questions. You just have to figure out your moments. This is your engineering science N3. All right. Then use the basics. Answer all the basics from there. So vertical reaction, you must consider what is in the vertical. All right. Moving on to another part. Now they want us to determine the horizontal reactions on the bearings R1 and R2. Horizontal. So you must consider what is in the horizontal this time, starting from the flywheel up to the end. Which ones do we have in the what? In the horizontal. All right. So let's figure out 1.4. So horizontal. All right. Reactions. So as for the horizontal reactions, let's consider the flywheel is not taken. Remember, guys, I told you from the first class that the flywheel only it is what? The weight. So horizontally, the flywheel is totally out. There is nothing to be taken. Then we move on to the gear, which is the gears, as we are to consider our gears in this case. R is having the horizontal. If FR is vertical, the opposite for FT. So FT is there in the horizontal. So we can use what? FT. It is horizontally given to the what? To the left. All right. Then we move on to the pulley. To the pulley, we are given T1 and T2. Only that. That is only what you're given. It is not an interconnection that we have. Vertical. There is no horizontal component. There is no horizontal force or weight there. We are not given the weight. I mean, the weight, still it was going to be vertical. There is nothing that is given in the horizontal for the what? For the pulley system. So for the pulley system, there's nothing. So the only thing to be considered here were the gears. and using what? Using FT. That is the only part to be taken. So how do we apply our FT? FT, you use it the way that you just apply your FR, or to say when it is going to the left, it is a negative, all right? To the left, it is a negative. So it was going to face down like this, all right? So this is, let's see our diagram. So you resketch your diagram starting from the beginning. This is R1, the bearing. They, if you consider, we have got our bearing. So that was going to be like this. Let us just have a sketch. You understand me very soon. So it was going to be like this. This is your R1. So we say there's nothing here on the flywheel. So this distance is just a distance to be taken, 0.1 meters, but there's nothing on the what? On the flywheel. There's nothing that you put. There's no horizontal. So the flywheel here, there's nothing. Just indicate the distance. It was what? 0.1 meters. So there's nothing that you put, that you indicate there. All right. From the flywheel to the gears now, that's where you consider the gears, where you have got your FT. From the flywheel, there we have got what? The gears, 0.35 meters apart. So the gears, that's where we've got our FT, which is what? Negative. So a negative, when you are to present it on your diagram here, it's going to be facing down. All right, that's a negative to show that's a negative. So that's your FT for the what? For the gears. That is the only one. From the gears, we move on to R2. At the end, we move on to the bearings. All right, with a distance of what? 0.35 meters again. Then to the end. So this will be R2. All right. Then to the end, where we have got what? The pulley. And on the pulley, there is nothing in the horizontal. So there's nothing to indicate. There's nothing to indicate, just 0.2 meters that distance. So there's nothing there to indicate. So this will be what you're having now. Calculate the reactions now, R1 and R2. So it's up to you. Like I said, as for me, guys, I'm just used to taking my moments about R2. So taking moments about R2, you just use the one that you are comfortable with. So I'm going to calculate R1. So taking moments about R2, it means this reference here, which ones we have in the anti-clockwise. Anti-clockwise must be equal to sum of the what? The clockwise. So anti-clockwise, that is FT. FT is moving this way, anti-clockwise, opposite of the clock. All right. So this is anti-clockwise. Then R1 to R2, this is clockwise, the clock in that manner. So that's it. So sum of anti-clockwise, we take them together. The anti-clockwise, that's FT times what? 0.35. FT times 0.35 must be equal to the clockwise R1. Remember the distance between R1 and R2 is what? 0.8. So add everything here. So that's equal to R1 times 0.8. Just like that. So FT is there. We want to calculate R1. FT, we calculated it before. FT is what? 3,200. You take that one, substitute in place of FT. So that was the idea. So FT is what? 3,200 times 0.35. And that's equal to R1 times 0.8. Simply divide by what? 0.8 divided by 0.8. This is going to cancel. We have got R1 in the space of time. So that's 1,400 Newton. Just like that. So this will be your R1, which is 1,400 Newton. All right. So you can place it. Our R1 here. 1,400 Newton like this. So meaning to say, to find R2 now, because this is another reaction, so we have to find R2. we can use the forces. Sum of forces up is equal to sum of forces down. Yes, it's like you're saying sum of forces to the left is equal to, but according to your diagram here, use what you understand. What is going up? What is going up? It's R1 plus R2. It must be equal to what? To FT. Simple like that. Don't complicate yourselves, guys. All right. So substitute what you have calculated. R1, 1400 plus R2 is equal to FT, and our FT is what? Remember FT, that's our 3200. So that's it. That's it. So 3200 here. So you can find R1. Taking 1400 to the other side is going to be a negative there. So meaning to say you're going to subtract 1400 from this one. That was going to give us 1800 Newton as the value of R2 for the what? For the horizontal reactions. You're dealing with horizontal reactions. So you've got R1 and R2 for the horizontal reactions. For the vertical, you deal with the vertical. Just analyze your diagram using the introduction part, how you're going to treat the setup of your gears. Is the driver below? Is it above? Is it to the left? Is it to the right? It affects your FR. Once you know the effect of FR, it is the opposite to your FT. So if FR horizontal, FT is going to be vertical. If FR is taken in the vertical, it means FT will be taken in the what? In the horizontal, opposite to that. Then the pulley has its own information. Like I said, if you consider the pulley system, how are you taking the pulley system? Is it going down? Is it going up? Is it to the left or to the right? But whenever you have got a condition where it is going up, like where it is taken up, then know that it affects the bearings. The bearings will be experiencing a downward force. So you have to change the diagram. But in our case, there was no need for us to change the diagram because of what? It was already acting downwards. So, meaning to say, our bearings will be experiencing an upward force. So, we don't change anything on that case. This is for you. Revise. All right. As much as you can. You see that that is it. So, as you consider the horizontal also, as you are to consider the horizontal, the flywheel is not to be taken. So you must test the pulley, but sometimes the pulley can be there on the horizontal and the gears. Those are the only two that you must test. All right. Those are the only two that you must test. In our case, it is only that it is given in the what? In the vertical. So you cannot fight that one to say it is supposed to be part of our horizontal. No, you work as it is. If we used it when it was for the vertical. That is the part of what? Of the pulley system. But for the horizontal, we cannot use that part of the horizontal because of what? We do not have it. But there are questions, if you check under membership, I've done where you can be given the pulley system having vertical and also having horizontal at the same time. So make sure you do revise such typical questions. They can be like that in exam. So you just have to go through a lot of questions as an individual. So that's it, guys, on these typical questions. That's it till we meet again.